Sucker free. Look at me. Da da dee 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 dee. Welcome to my stream. Welcome to my stream. Now you really know everything I mean. Just kidding. I'm not quite that weird, but I'm getting there, brother. Welcome everybody to the what do we at, Jared? 62nd episode of the Swift and SwiftUI Learnalong. I am your host, me, and per usual, we're gonna start out with a little intro here that I like to step folks through. Okay, just so you know what you're getting when you're getting it. So, first of all, this stream is cathartic for me. Yes. It's not a direct interaction stream. It is something that you are, true to its namesake, learning along with me. So I'm not teaching you stuff, nor am I even really aware that you're even there. Although I see the follows, so I appreciate that. Thank you guys. But yeah, just know that you're learning this literally along with me. I don't do anything off the stream. So it's a way to keep myself in a good rhythm. It's a good reason to come back, continue to do it. So, yeah, I mean, all feedback is welcome, but there won't be any direct interaction while we're doing this. And in terms of what we intend to do fully is, of course, learn Swift, learn SwiftUI. Everything that we need to do to build a real-life product, because that is the end goal here. So I am technically a business owner currently, started a company, and this is going to be the first product. And so I come from about a decade of experience in the software space, working for a service company. We resold an ERP and had a plugin, blah, blah, blah. Did a lot of SQL, did some Golang. Never written a full-blown application myself, but that's the goal here. So that's what we're learning. Now, we've already gone through one book. So what I like to do here is just purchase, or find, I shouldn't say purchase, not everything costs necessarily, but I like to find books and courses that I can go through, hopefully visual in nature. Found some really good ones, and I narrate the book out loud and do the code samples. So pretty straightforward. The first 46 episodes of this stream, and now this is in relation to how you yourself can get caught up. So if you don't know Swift and you want to go through those pre-recorded episodes to get caught up, go to this YouTube channel here, Nico X Narration. And roughly the first 46, they're all in sequence, they're all in order, are going through the Big Nerd Ranch guide that teaches you Swift. It's effectively a deep overview, if that makes sense, of the entire language. So you won't come away with the mastery, but you will know everything that Swift can do up until 5.10. It was a great book. I felt like we learned a lot. I learned a lot. Hopefully you guys did too. But yeah, just know that we've already progressed past that point of the basics of the language. Now we've moved on to SwiftUI. And you know what? I should just put it here. Big Mountain Studio.com. Now, Big Mountain Studio, I have no affiliation. I'm simply a customer, but that is the book that we're learning SwiftUI from. And you know what? I'm going to add to this SwiftUI and Swift data, because I was unaware initially, but this is also a large component of it. So Swift data apparently is, and I say this with no sarcasm, but every bit as important as SwiftUI. It's the framework that lets you work with memory and make calls to databases, blah, blah, blah. So that's what we're doing currently. And Big Mountain Studio is this book here. So they have awesome stuff. And what's neat about these guys, because I was worried about this initially, I'll say it every stream. I know it's redundant, but you know, there's issues with copyright, obviously, if you're purchasing something and then sharing it online. Now you can argue fair use stuff, blah, blah, blah. But the good thing is none of that matters anymore, because Big Mountain Studio encourages content creators to use their stuff, and all they ask for is a shout out. So God bless you guys, and this is my shout out. And we'll do it again at the end of the stream, just in case. So yeah, they make great stuff, and And just as a look ahead for what's coming next, we're definitely going to be back. So they're going to get their money's worth out of me, and hopefully a few more folks go check out their stuff. But really and truly, this is the only, I probably looked through 18 different sites that were, Swift centric. The big ones like Manning really didn't have anything up to date. And then there's Codeco, which was pretty good, but even that stuff wasn't really up to date yet. Big Mountain Studio not only has very visual type of learnings like this. I mean, look at this. This is great, right? You got all on one slide. You get to see the behavior of the thing. You have the code itself, and then little explainers for portions of the code. Now, I don't know about you guys, but if you don't know a programming language, this, in my opinion, is going to be the best approach to learning the concepts, because it's, the syntax is one thing. It's easy enough. A lot of that is just repetition, but to really grasp the concepts, especially for a framework like SwiftUI, I think this approach is great. So, yeah, I love their stuff. We're going to come back after we finish this one. I think I'm going to come back and either do this one here, the animations mastery. I want to do, lots of animations. I want to learn how that works, maybe even dink around with some gaming frameworks in the future. So we'll definitely come back for at least the animation mastery, and we might also do one of these other objects here. But yeah, come check out their stuff if you like visual learning, because I think this is easily the best that I've come across online. And if y'all know of any others, feel free to send them my way. It's just good to have all these sources. I honestly am surprised that, I don't know, Swift I guess it makes sense because it's always been thought of as a Apple only type programming language, but that's not true. But anyway, there's a big announcement coming. We're getting Swift 6.0 later this year. And supposedly there's going to be more of a marketing effort to spread the good word that Swift is more than just an Apple ecosystem programming language. You can write what they like to call server-side Swift. So, on your typical AWS container jobs, or, whatever, any other server running Linux, even on Windows, you can run Swift on Windows. Can you believe it? It's true. It's officially supported on Windows. But yeah, it's powerful stuff. And let's pick up where we left off yesterday, which yesterday I wanted to talk a little more about this pre-filtering, because I almost drowned on my own water bottle. I forgot that one has a straw, you don't got to swig it. But anyway, yeah, this is where we left off yesterday, pre-filtering. I was kind of getting hung up, whatever you want to call it, on this portion, just because the pre-filtering sounded a bit overstated. But they were effectively describing this notion of having these two different, my cursor pro, my little magnifier assistant. Yeah, so you see these query macro, right? So we got two of them here. And the idea was that when we feed it the model, in this case, park model, so that's what we want the wrapper to apply to. And then here we can apply a filter. So this was another macro predicate, and then our conditional. So this is, wrapped in a closure. And this is just saying inside of park model, take the whatever's at the first position in the array, since it's a 0 index, so 0 is the first one. Only show us countries where the property country equals United States. So just two different filters here. But the way they were describing it was a bit, not like they're trying to get one over on us. I'm trying to think of the right way to articulate this, but anyway, my only issue with this is they're saying that when you write this code, what they're really saying is the filtering is taking place in the data source. So like if we were using SQLite, then when we compile the application, the SDK or whatever allows us to talk to the database, in this case SQLite would do the filters for us. So the database app itself would do the filtering, and only the filtered data would get into memory, into context, our context that we want to use for our app. And all that's true, and that's great, but in reality, I mean, that's always going to happen. Like, you would have to try very hard to explicitly write code to say, okay, load the entire database into memory, or the entire table into memory, and then filter it. You know what I mean? But anyway, I was going back and forth with Gemini and sorted that thought process out. So let me just step you through that real quick. Maybe, we'll see. I don't know if there's much there to be gleaned, but there was one portion, I just can't remember what exact words were exchanged, but I felt like it was worth reviewing. So, oh yeah, here it is right here. So, or no, let's start up here. Let's see. Okay, so I asked, please explain again without using Firebase as the example instead of SQLite, because he kept trying to sell us Firebase, or we're trying to just ask it a question. Firebase being it's a data store, it's a SaaS product. Okay, so effectively, this is where it's describing what I just said, where it's using the, in this case, SQL, the conditional, which is no different than ours. That would be the equivalent of this here, the where clause. Just like saying this. And so it's saying when you build your app, it tells the database to apply those filters, and then whatever optimizations the database engine has for this is what we get. So I mean, you're controlling it in the sense that you're saying, yeah, this is my conditional, but beyond that, the optimizations are just up to the data source. You're not, unless you want to go over there and also write custom code. But so that was the first part, right? So the application engine itself, or the database engine itself, is taking care of the quote unquote pre-filtering. All we did as app developers is write a conditional. So that's why I kind of thought it was a bit overstated, because it's syntactically, you know, you look at this and they call this pre-filtering, right? So we have two separate queries, two separate conditionals, one for Canada, one for the United States, right? But then if you look at this one here, multiple filters, but not separate queries, just one query. By their definition, I mean, you're still pre-filtering. It's just not two separate queries that exist separate from each other. But you're still always doing the filtering ahead of time. You're never loading the entire thing into the app and then applying the filter. If you're pulling it from a persistent data store, the filter occurs in that engine. So if you're going over the wire to a server, the server does the work. It only sends the filtered data, and then we load that into context and use it in the app. So anyway, I'm not trying to say, oh, I'm a genius, I proved them wrong. It's not about being wrong or right. That stuck out to me, so I wanted to reiterate that, because I was stuck on that yesterday, and yeah, it didn't really make a ton of sense. But that's effectively what it's saying. So it's kind of like, what's a good example of, you know, like when someone comes along and tells you that, hey, you should, wow, that's a terrible example, actually. Effectively just trying to more or less describe something in a way that makes it seem harder to accomplish or more complicated than it actually is, when in reality, it's more like looking both ways when you cross the street. Like, it's almost a given. Now, not everybody has common sense, but we can make an assumption that most people know to, you know, look both ways or don't run a red light. You understand what I'm saying? So that's kind of the spirit in which I was questioning it. But anyway, Gemini says, yeah, naturally, because they're always going to agree with you. But so pre-filtering, I say, seems a bit overstated. Seemingly common sense to not query the entire source, load it into memory, then filter it. And then it says that's correct, and that's effectively what it's describing. But that's fine. I mean, again, not everybody, maybe that's not common sense to everybody. I don't know. But I just wanted to close out that thought. All right, now then. Let's go back to dynamic sorting and filtering. So this is now our pickup point. No longer review. All right, Jerry, got that timestamp? All right, brother. Okay, dynamic sorting and filtering. This section will teach you various methods for changing the sorting and filtering of data while your app is running. This section will teach you for changing the sorting and filtering of data while your app is running. Okay. Pardon me, ever so kindly. Okay, these methods are often referred to as dynamic sorting or dynamic filtering. There are multiple ways to implement dynamic sorting or filtering, each with its own advantages and disadvantages. You will learn about these different methods so that you can make an informed decision about which one to use in your app. All right, cool. In-memory and requery. When a filter or sorting criteria change, you need to update the data. There are two primary ways to do this. One is in memory. When a filter or sort criteria change, you can change the data in memory using Swift's built-in array functions for filtering and sorting. So from the persistent store, so like a database, sends the query data into memory, into the model context. And then as the criteria changes, sort or filter the array of models already in memory, which is what we've mostly seen in terms of what we've covered in the books already. And then requery, when a filter or sort criteria change, you run your query again with the new sort and filter criteria and repopulate the data in memory. Is this? In memory, yeah, okay. So when a filter or sort criteria change, also rerunning this whole thing instead of just applying it to what's in memory. Yeah. Okay. Sense. Query and model changes. Okay, yeah. So just a repeat process. I mean, you wouldn't be able to, like with, okay, so the app that I'm going to build is going to load data over the wire. So it'll be a HTTP call on the initialization. And maybe, I guess we could cache the data that was worked with previously. That might be a good idea. But in order to get an update of the most recent data, that would need to come from the customer's SQL database. So in that sense, we would always have to requery if that was the request. But if it's something that can be done with the existing data, then we would want to cache it. So I suppose we'll need both. Okay, so which one is the better method to use with dynamic sorting and filtering? It depends, of course. Processing time, number of models. Yeah, there's an inverse relationship there. During testing, it was found that in-memory sorting and filtering performed faster with a smaller number of models. With a large number of models, it took significantly longer. What is the magic number of models when in-memory becomes slower to filter and sort than requery? It'd have to be some kind of... I mean, there's a lot that depends on. Like if you have a lot of RAM, like my Windows machine has 64, so like that could handle a lot. So it'd probably be a while before, well, provided that's the only program I was using it for, but yeah, it all just kind of depends. But at some point I would think the network latency, because if you go over the wire, you have to account for your network speed, the time it takes once you get to the server to make the read, the time to encode that data, and then also the time to get that response back and then decode it. So there's a lot of steps if you're going over the wire to get data versus just handling it in memory. So I mean, I would think that would be, well, I don't know. That's as much as I know. I don't know the answer. That's always hard though. I mean, I've never, even with SQL, any kind of optimization or trade-offs is always difficult whenever you're talking about a server that's sharing resources. So it's really becomes a bigger conversation because we would hit this all the time, but customers like the warehouse people, because in a past life, an entire company would be using our software, meaning that's what they run their business on. It's a ERP software. So people in the warehouse that are scanning inventory, and the billing department, the CEO is reading income statements out of it. Like everybody's using it. And generally speaking, it's always reading from the same SQL server. But if your warehouseman is complaining, about how slow the software is or whatever, and you solve his problem, you might be making other trade-offs elsewhere in the program. So it's always it's difficult because a lot of times with, like in our case, indexing something, which is a way of it's a way of speeding things up where you have identifiable keys. So if you have, like, say, an item table and all the item IDs are going to be unique, you can create an index to help speed up lookups in that table if you know that you're going to be constantly looking at that table. And people always are. They're making orders. People are calling, asking about new products. People are looking at stock levels. So that's a table where you would absolutely want an index. But that also slows things down whenever you're writing new records, which that's something we learned yesterday. So there's always a kind of, there's a balancing act that you got to play. What is the magic number of models when in memory becomes slower to filter and sort and recreate? It all depends on your model size, number of properties, types of properties, relationships, and which kind of property you are sorting or filtering on. As a general rule, you can start with in memory, and if you notice any delay, switch to requery. Yeah. Yes, and this would always frustrate me for a long time, but the fact is, you just got to embrace that detective process and find a good set of tools, understand your environment, and then just test stuff and try things. Otherwise, you'll remain frustrated because there's never a clear answer for your environment and your situation. They used to always bother the hell out of me, but what actually ended up helping me was, stuff like this, just going out and finding not these broad spectrum books, but finding books that focus on a singular technique, like optimizing or query profiling, stuff like that. Let's see, in memory. And a matter of fact, the only thing I know people, it's still pretty popular, but Stack Overflow. I think the best thing, or really the only useful thing I ever found there, but it was very useful. Tons of great examples of stored procedures for like backup jobs or disaster recovery, and a lot of great conversation around that. For whatever reason, maybe it's because SQL is just the crowd that it brings on Stack Overflow. I don't know, but the conversations there were always pretty fruitful, and there's a lot of really good examples that are well laid out, and didn't really find that to be the case with most other things. A lot more opinions involved for other domains at site. But yeah, nonetheless, we got AI now, so we just read up all their examples. We don't have to go there at all. They had it coming. Okay, so in memory, advantages, disadvantages. Easy to set up and use array functions you might already be familiar with. True. Fast with a small number, doesn't scale, slower with a lot more data. Yeah. Just as a quick aside, what's interesting here though is like the whole in-memory thing. although it becomes a lot more expensive, frameworks like Spark for big data jobs, they effectively let you take multiple machines, servers, and using Spark's API, you can manage those, or it'll do it for you rather. So you just do some simple configuration, and Spark uses that cluster and treats it as though it's just one big ass powerful machine. So when you write code, you can write code as though you're writing it for, local arrays, just like this, which is really nice. And well, nice and torturous, but because it's not as easy as I'm making it sound. There's going to be hiccups, but in general, just I suppose be aware that there are frameworks like that. There was another, there's a really good, if you like podcasts on technical things, look up on YouTube, Developer Voices. He being Chris, he's the host. It's this older man with long white hair, can't miss him. Look up a video he did on Spark or Flint. Either one of those would be good interviews to see. Or even, there's one called, what is the Golang? Framework for big data pipeline that starts with a B. This person that started this framework is also on Developer Voices, but it has a weird ping. Benthos, yeah. So let's see if I want to make sure I'm telling you right. Benthos. There you go. Yeah, this thing. So you can search Developer Voices Benthos. Any of those would be really good. But yeah, if you're out on the job market or looking for a job or trying to get into DevOps and stuff like that, these kinds of frameworks you're going to work with a lot, or some version of them. This is Golang's, there's a whole bunch that are popular now, but yeah, check that out because that's really interesting and it describes a lot of long-standing issues around this particular problem. But yeah, the takeaway is there's no real answer. You just gotta know your tools, know your environment, and how to test things. Okay, requery advantages. The persistent store is very efficient at sorting and filtering a large number of models. Scales very well. Disadvantages, takes more work to set up and get it working. Slightly slower with small number of models, usually imperceptibly. Yeah. Let's take a look at examples, starting with in-memory first and then requery. Okay, so this is in-memory sorting. This is what it looks like. Okay, so we're all familiar with that, hitting the little sort button. That's literally what it's doing. Okay. So that's dynamic sorting. Let's see, struct, query sort dynamic, type view. There's our query wrapper around the park model. State to make it observable, aka reactive. And then, what is this? Private var. Oh, so here's our sorting. So there's the opening closure, parks.sorted. All that method, one part two, in order ascending, or in order ascending. Oh, right. Yeah. Okay. Ternary. Man, they get me every time. Okay. So it's either this, and then this is the separator, or this. So it's going to base it off of these two, less than, equal than, And so when we flip the switch here, this switches between ascending and descending. Okay. So it's checking for ascending order. If it's not true, flip it. And it would always be okay, yeah, that's right. Yeah. Okay, no, a new query is not being performed here. New query is not being performed here. You are only sorting what has already been fetched in memory. Okay. Which I believe is easy enough to identify since there's no wrapper around. But there's no, this is the only query that's happening here. Otherwise, we'd see it like this here. Two separate queries. Only sorting what has already been fetched. Yeah. I'm just pulling my beard here. Okay. The idea here is you do the query once and then sort locally. Sending. Or fill. Wait, so that thing is... Oh, I see. It is filling. So descending is filled. Which makes sense because this up here is our descending logic. Symbol variant modifier allows you to programmatically change the characteristic of the SF symbol the button defines. Yeah, this is so cool. Again, the SF symbols, if you recall, for developers, you can just get to it in Xcode, this little plus sign up here. So these are, like whenever we, in SwiftUI at least, in that context, when you see it refer to, when you see a view refer to system name, it's referring to the name of these SF symbols that Apple provides here. So these are all just different little logos that we can use. I'm sure all look familiar in all the apps that we use. And then there's also this for designers and whatnot. So if you're not a dev but still want to work with the symbols or just want them in general, SF symbols, this is a standalone free app that has all of these symbols from Xcode plus a lot more that you can download that come with it, but it's all free. So that's really nice. But yeah, Swift is working directly with these and allowing you to fill. Or wait, you know what? I think it's... Oh, I didn't realize that. So I wonder if it's only... You see how this pencil... Yeah, shit. Pencil, circle, fill. I search pencil, circle. Is there a... Oh, okay, I was wondering if, because you can base these on percentages. So if you wanted to have it start empty and then tie it to, like, say a list of 10 tasks, and each time that they completed one, you'd fill up 10% of this circle until it's completely full, representing all tasks are done, that kind of a thing. You can do that here. So programmatically, you can modify these SVGs. So it's pretty cool. But that's what this is doing here. So none and fill. So this thingamabob here, if you watch it, is flipping. It's flipping, brother, between unfilled and filled. Pretty cool, eh? Okay, so now that we understand that, or what do we understand? I guess this is just saying, or describing the fact that a new query is not being performed here. This is just what's being done in memory. And if you go through the first part of the stream when we learned Swift, I mean, this looks like just normal code, or what we would have referred to as normal code. So nothing new in particular that we haven't seen, just a way to understand it within the context of this example. All right, so what's next? Sort code options. There are a few different ways you can write the sorting logic. No specific way is more correct than another. It is up to you or your development team's standards. Long version, private var, sorted parks, park turn, sorted version of the parks using this logic. If order ascending is true, then park one name, order that above the next. Otherwise, okay. The sorted function works by comparing two elements of the array, park1 and park2. Instead of an if statement, you can use the ternary operator, that question mark, this thingy. Which the ternary is shorthand for if else, but you're saying the same thing. So like this logic, park1 name less than park2 name is the same here, as you can see. But instead of all the brackets and whatnot, we just use this for the if else, and this is this semicolon. Wait, no, that's a colon. That's gonna bother me. The colon, right? What is this? What is it talking about? Okay, it's a colon. That's what I thought. Okay, so instead of an if statement. Oh, yeah. Okay, so the return keyword is optional if there is only one statement in the closure or property. If there is only one statement in the closure or property. Okay. That's why we don't see explicit return there. There's an implicit return there. This is true. False. No. All right, and then a short. Ooh, that is very short. Oh, we saw this. So the index 0 and index 1. So the first and second positions of the array, which can be used in place of the parameters that are passed into the closure. Swift calls this notation a shorthand argument name. More info here. Oh, that's just everything on closures. We could do a whole stream just on closures. Maybe someday, but let's go back. Wait, but it's saying order ascending. Oh, we don't need the, I see. This is now gone. How is that possible? Mark sorted. Oh, because these are addresses. We know what it's pointing to. Okay. Where is the... Okay, no, we got there. All right. So 3 different ways to write that same sorting logic. Now, which one do I prefer? Probably this one. Shorter. Not shortest, but shorter. This would be... That's too error prone for me. Even though by this point, I mean, I'm used to the fact that there's zero-based zero-based indexes, but still, it just, I don't know. This is just as well. So yeah, I think I like that one. Matter of fact, this here. Okay, comparable. Sorting works by comparing two values and seeing which one is greater than or less than the other. You specify explicitly which model property you want to be sorted in the sorted function. There is another way to have sorting done implicitly, so you don't have to tell it what to sort. This is done by making your model conform to comparable, which is a protocol we learned that requires an equality operator and a less than operator be defined for your type. As long as it has that, then it can conform, and comparable protocol, by virtue of doing that, the compiler will create the rest of the implementations for you, meaning you give it equality and less than, and then it can give you greater than, equal to, less than or equal to, or less than and equal to. Okay, which is nice. You don't have to implement them all yourself. So, okay, so specifying what makes one model instance greater than or less than another model instance. Yeah, and that's what's cool and I guess dangerous in some sense, but more cool than dangerous, that Swift lets you define or even redefine operators using your own logic, which is pretty cool because that means that you could use Swift to write all manner of like DSLs and stuff like that, which I love stuff like that. Yes, I mean, I would imagine whenever this gets, I mean, there's already a decent amount, but when Swift continues to rise in popularity, just there's going to be some crazy convenient frameworks, I would guess. And I'm basing that off of, but we'll cover it. I meant to look at it yesterday actually, but there's an HTML implementation that somebody did in Swift that I want to look at the end of this stream. But it's a good example of that. Okay, so the model here, what do we got? 1 and 2. Extension park model comparable. That's how we make it, or that's how we tell the compiler that this conforms. Static func less than, so static func being a type property. RHS. So LHS left hand side, RHS right hand side. Park model, and this returns a bool, which is a true or false. And then there's the comparison. Okay. And then in the view, private var park model parks.sorted. Sort of, oh, because that's the default, so no arguments here. Descending parks.sorted by, sorted by, greater than. Okay. Z to A instead of A to Z. The sorting function on the view becomes even simpler. You no longer have to say which property to sort. Property to sort. Wait, but how? Get there. Inside park model. Bool. Oh, duh, right here. Okay, so this is where we're getting it from. So the dot name property. Okay. No, okay, yeah, that makes good sense. I like that. That one too. I think well, I'm just gonna do this for now, but Swift Example. Yeah, they're getting their game up. Good old Zeit. Okay, so comparable multiple properties. Parks are now sorted by country and name. But oh yeah, U is before W. Duh. Okay, United States, Wyoming. Yeah. EG. Okay, and how do we do that? Sorting multiple properties is not so obvious. You want to sort by country first and then by park. Within that country, you will have to check if you are within the same country first. Use Swift tuples for even shorter code. Country is compared first. If equal, then the name is compared. This will continue as you add more properties. Okay, so let's see. This is variable extension, static function. Here's our if. If the country on the left-hand side is equal to the country on the right-hand side, turn in ascending. In the same country, sort by park name. So first we return sorted country list. So okay, I guess that runs first before the if. That's what it's saying. But I mean, it makes sense. I would have thought it would have been top down, but I guess not. Confusing. Okay, so if oh, okay, I get it. Yeah, okay. So because they might not always be the same, you're always going to run this regardless. You're always going to make this comparison. Meaning left-hand side country, right-hand side country. Always. But the conditional here only runs if they're the same. So United States or Switzerland, whatever. And so if they are the same, then instead we return the sorting against the name. So we know the countries are the same. Okay, that makes sense now. All right, a shorter version, extension still, type property. This is a generic, so that's why. So the thing throwing me off here is that less than symbol after the func. What is that? Oh, we're actually naming it that. I see. Oh. Weird. Okay, so the operator is actually just a function named as a symbol. Hot dog. Okay, so static func less than then our function signature here. Function body is here, so we return name less than. That one is a little, probably a little too, like I would know. I couldn't explain that one to you. Just taking their word effectively that it does the same thing as this. So I'd probably stick with this for now, but cool that you can do some shorthand. This will continue as you add more properties. So here's an example of 3, country name. Well, I guess it does make sense because in the first slot, because we know the function is a comparison operator less than, so it's left-hand side country, right-hand side, second position, name to name, rating to rating. Okay, maybe that's not so bad. Okay. In-memory dynamic filter. Let's see what that looks like. Okay. Now how did this differ from the other one? I don't really. We go back to in-memory dynamic sorting. Oh, right. Okay, so just sorting, not filtering, but here we're actually filtering some data. Okay. So let's see. I'm not tired, you're tired. All right, start with a query that has no filter. Start with a query that has no filter. So we'll retrieve all the data. Yes. Everything from that array, park models. From here, you can use the filter function on the array of data. Oh, here it is. Yeah. That modifier on it. Every park name. No, not park name. For every country attribute. We only want the ones back that equal Canada in this case. Otherwise, turn all. Okay. Sense. Filter. Have your list use the filtered property, not the query property. Have your list use the filtered property, not the query property. Oh, okay. So not just Canada filtered parks, because that's what this is. Okay. When you tap the button, the bound state property just Canada, which is here, defaulting to false. Bound state property changes value, which triggers a redraw, and the filtered parks is called again. I see. Okay. I wonder if what the difference is then. Let's see. We'll ask Gemini. Only copying text out of these didn't suck. Is there a way to look at this? Not really. Gave me. That's good enough. I'm just curious if that's also, or if that $ syntax is the equivalent of the escape character, like because that's what we've seen before. So I just want to know the difference and how we can use those. Given flow code. Canada. Does that differ from using the damn. Okay, so the $ is a property wrapper binding. Oh, okay. Yeah, it's all rushing back to me. So we can only use that if we have a property to latch onto, which in this case is the state here. At state is wrapping just Canada. That's why that works. Otherwise, okay, yeah. So now I realize it was a silly question, but good to know. Yeah, this is for string interpolation. Pulling it in anywhere. Let's see what it says. Might learn something else. Okay, property wrapper binding purpose. This syntax is a fundamental part of SwiftUI's data binding system. I guess that's another good thing to point out. It's $ syntax is SwiftUI, or valid in SwiftUI, but not Swift proper necessarily. It is not just about displaying the value of just Canada. It creates a two-way connection so that it can re-render and update and understand when it's changed to invalidate the view, and then redraw it so you get updated data on your view. How it works: state connection. The state property wrapper makes just Canada a source of truth for the view state. And dude, binding the $ prefix turns just Canada into a binding. This means that changes to the toggle, which is bound to just Canada, automatically updates. Dynamic. Yes, there's a bit more to it here. Variable. Yeah, and that we've seen. Okay. Let's see. All right, I think we beat the hell out of that horse, so let's go on. Filter code options. Code options are just for you to consider. No specific way is more correct than the other. It is up to you or your development team. Okay, filter code options. The long form of this code makes it easy to read and follow the logic. Let's see. Private var filtered parks of type park model arrays. If just Canada is set to true, then return filtered set of parks where the country property is equal to Canada. Otherwise, return the entire list of parks. And then the shorter version, instead of an if statement, you can use the ternary operator and shorthand argument. Remember, the return keyword is optional. Yeah. Okay, I mean, I guess they're just reiterating here. Looks a lot like what we were shown earlier. Okay, so now requery. When it comes to requery, there are two methods you can use to create a new query to run again. When it comes to requery, there are two methods that you can use to create a new query to run again. Subview query, parent view. Sort and filter criteria are selected on this view and passed into the subview's initializer. Sort and criteria, the sort and filter criteria are selected on this view, passed into the subview's initializer. Oh, okay. Sort and filter criteria are selected on this view, as in user controlled. So through some menu or whatever. So just like this little button up top would be an example of that coming from the view. So that would get passed into the subview's initializer, which would be, I mean, this is not the initializer, but that's how we could change an instance's value of it to true, for example, here. So we take whatever the view gives us in terms of filter criteria, pass it into the initializer, invalidate the current view, return the subview. Inside the init, the at query is recreated with parameters passed in and rerun to return the models. Okay. Second method is fetch. Parent view, the sort and filter criteria are selected. It's the same process from the end user perspective. Selected on this view and a fetch function. So now instead, the inputs, the filter criteria would be passed into a fetch function. And the server would do that work, and then we just return the filtered data. The fetch function is equivalent to running at query to get data. Yeah. Yeah, if you've ever worked with the web or intend to, there's a browser implemented API called fetch. So I mean, you'll get used to that terminology, but yeah, fetch. Actually, in every sense, everywhere I've encountered it, which is a good thing, it always means request to the data source for data. Not localized, not cached, not memory. How do they compare as far as performance goes? They perform the same. They are fast and both scale very well for large numbers of models. Wow, I mean, oh, okay, so they're just talking architecture here. So either there's just a raw function that takes those every time, or you can separate parent view from subview inside the, and I guess just in the subview might be more complicated. I mean, I guess you could be the trade-off there. I guess if you wanted to have it all in the initializer, instead of having a separate fetch function, that might be a reason to use number one. Perhaps, maybe so. Are there any drawbacks to either of these methods? With the first one, you have to create a subview to make it work. With the second one, you have to manually refresh the view if any changes are made to the models. Oh, no. Insert, update, delete. You will learn the solution. Okay. Requery, subview query. Let's watch this bad boy here. Toggling the sort and the filter. What happened though? Sort, then we apply the subview. That remains while we can change the sorting back again. Is that what happened? Yeah. Z to A, subview, A to Z. Okay, that's what happened. All right, to make the subview method work, you need 1, sort filter values, 2, the subview to pass in your values to create a new query. The subview to pass in your values to create a new query. Okay. So there's our binding for state. Sort order and filter on. These are the default values. Subview on the next page. Park list view sort order. Sort order. So this, whatever that value is, gets passed in here as an argument. And filter on does as well. Note, as your sort filter values change, SwiftUI sees your subview is dependent on them, and so the subview is recreated. Okay, so that was number 1. And if that gives us automatic updates, it so far seems like the obvious choice, I suppose. Plus, this does not seem too complicated. I mean, nothing we haven't already covered. They're just describing it more deeply. Park list view. Create a query like you normally would, but then in the view's initializer, you use the parameters to construct your sort and filters to create a new query. Create a query like you normally would. So we're still doing query, park model. But now in the initializer, you use the parameters to construct your sort and filters. So the underbar by convention is just effectively to say it's an implementation detail, and you shouldn't really dink with it. So other people using your code know what it's for. That's what that means. Parks equal, and then here's the new query filter. Filter on, or filter nil sort. Okay. So if there is a filter on, use the filter view, or filters nil, apply the sorting still. What is underbar parks? The underscore in front is what gives you access to what Swift calls the property wrapper's stored property. It is underlying object. Wait, what? It's called the underscore in front is what gives you access to what Swift calls the property wrapper's stored property. Okay, I was way off. Where did I get the underbar thing from? I'm pretty sure that's... Hold on. Of the leading. Yeah, private internal use score for internal use within a class and not part of the public interface. This convention is less common now that Swift has explicit access modifiers private. Oh, okay. Okay. Well, that's not what we read, but that's okay. I mean, we learned about private, file private, all that. I guess the Big Nerd Ranch Guide encouraged us to basically do both, but yeah, it doesn't really matter. Okay, so that's good to know. So in that case, then, what you call it? SwiftUI has its own definition for that then. So that actually controls some behavior in terms of SwiftUI. So let me see if it knows that. How does differ in the Swift? Okay, yeah, so it does mean something entirely different. All right, so that's good to know. Use a property wrapper like state binding observed. I create an underlying storage variable for that property. Oh, right. Yeah, weird. That was a very took me a while to grasp that whole concept of what it was doing in the background for you. For instance, if you have at state var count equals 0, you'll also have a hidden variable underbar count that holds the actual state instance. Yes, you always have a way to refer back to what it was previous, which is cool. I just couldn't understand how it was doing that, but that's how the compiler is creating that for you. So whatever you named your variable here, it creates that for you. Huh. You can directly access this underlying property wrapper instance by using the leading underscore. This is typically done in the initializer method or when interacting with the property wrapper's specific functionality. Without the underscore, you are interacting with the wrapped value or projected value of the property wrapper. Wrapped value is the underlying data. For example, the integer in the count variable. So, okay, that's the wrapped value. Yeah. You're interacting with the wrapped value or projected value. And the projected value depends on the wrapper type, a binding or state. Okay. So this example, we have a property wrapper state for our count, which is an integer. Var body cube. And then in our initializer, accessing the state instance, count is equal to state initial value 5. With a different what? Different value. Why would you do that though? Underscores of well-defined purpose tied to property wrappers. A use case for different value versus custom initialization with default fallback. Imagine you're building a view where the initial count value might come from different sources. User preferences, if the user has previously set a preference for the count, start with that value. Default value. If there are no preferences, you want to use a sensible default, e.g. 0. Well, okay. This one's wrapped. But in the initializer, Still not braining on that one. Wrapped value count. This variable starts at 0. Okay. The default value for integers in Swift. The value might never be used if there's a user preference. Okay. Okay. But okay, I guess that racket out there. Just don't get how would it be in your source code if it's the user's preference? How would it already be there? State instance underbar count in the init method. You directly access the count property, the state instance. We use conditional logic to set the initial value based on the user preference. What is happening? Earthquake outside. Why this approach? Flexibility, full control over how the initial state is determined. Separation of concerns. Logic for initialization is separate from the view's main body. Getting the code more organized. You're working directly with the state instance, which is the core of SwiftUI state management system. In most cases, you won't need explicitly access count. SwiftUI's property wrapper system handles the state updates automatically. This approach is helpful in specific. Okay, well, maybe it's much ado about. I mean, I don't really understand why that would be the case. Then again, that's coming from Gemini, not this book. So AI is not clearly is not the end all be all. I gotta be honest with you. I think I'm regretting. There's a clear difference in quality. I mean, I'm not saying my prompts are all that, but Google's larger context window in comparison to OpenAI doesn't mean shit because it can't. It's just not as good. It's just not. OpenAI, ChatGPT certainly makes some mistakes, but the way that, yeah, I don't know. I'm getting some buyer's remorse here, but I did get 4 terabytes of G drive, so it's hard to turn down that offer. But yeah, I think this is not great. I like that it cites it for you. I'll give it like another month. It'll catch up eventually. I don't really lean on it that much these days anyway. It's easy to kind of romanticize things, you know, after it's been a little bit. But I mean, ChatGPT made plenty of mistakes too. You should have to, or not have to, you should check your work always anyway. Every time I've done a, copy pasta from ChatGPT, there's going to be lots of errors for anything but the most simplest thing. But yeah. All right. So I'm just going to take the L on that one. I didn't necessarily get that. I'm not going to harp on it. If we're not going to be accessing the state directly anyway, then I'm happy to let SwiftUI handle that. Parameter constructor sort filters to create a new query. This part at least makes sense to me because we're just creating a new instance of it, but okay. So what is parks? The underscore in front is what gives you access to what Swift calls the property wrapper's stored property. It is the underlying object query as opposed to park model. Yeah, that's a little funky, just all around. So there's parks, and then the compiler creates for you parks. You would just have to know that. Okay. Is it common to access stored properties? Not really. I expect Apple will change the way we can do dynamic queries in the future. Oh, okay. Preview, park list view, sort order forward, filter on. Yeah, they probably will because it changed even from 22 to 2023. And with 6.0 coming out, we'll probably see yet another change. Ah, the joys of being a developer. Okay, so now requery fetch. These are all macros, the environment we want to use, defining our state. As you change sort and filter state values, the body is redrawn and the computer property filtered and sorted parks is called by the list. Turn try, model context. As you change sort, body is redrawn, called by the list. Called by the list. Where is the list? Park row view. Oh, here it is. List, filtered, and sorted parks. Oh, okay, and that, okay. Calls it up here. And the return is a fetch call into the context. Okay, brother, I got you. Okay, so that makes sense. That one makes sense to me. The model context fetch function is useful, as you will see later in this book, but it will not update the view if models in the context change. See the next page for the fix. Wait. This book, but it will not update the view if models in the context change. Fetch, refresh. Oh, wait. So if we add... Babe, come on. It's a lot of racket. Girl. Titan out there in the living room. All right, let's add a at state property. Okay. Change the at state. Sorry, I got distracted. My office overlooks the apartment pool. Just saying. All right, so where were we? When the ID property changes, the view is updated. ID.refresh. @query has the benefit of updating the view when models in the context change, but the fetch function is simply read-only and will not update the view as models in the context change. But the fetch function is simply read-only. Fetch? Maybe that's just pseudocode. I don't know, but what is dot fetch? I get, but what is... Okay, okay, so it's read-only then. To trigger view updates after you make some model changes, insert, update, or delete, which in this example, it's adding or inserting a new record. You can use the ID modifier. When an ID value changes, the view is updated. You will see this technique used again later in the book. Toggle. Fresh is a state property, so that's being monitored by SwiftUI. We toggle it true and false. And since... Oh, okay, so we're using that. I don't know if you call that a workaround or what, but okay, so by doing that, we can always ensure that it's getting rerun entirely, which would capture this. Is that what you're telling me? It will not update the view as models in the context change. Okay, but this is a very specific instance. If the model didn't change, then this wouldn't apply. But if it does, we would have to use this technique. ID modifier. So, okay, but is that tied to query? Let's see. What is this? Query fetch refresh. Yeah. And so the there. Toolbar? That doesn't seem right. Where is the... Turn. guess you don't have to define it directly in the view at all. It's just there. Oh, yeah, we learned that through. Okay, my bad. Because of the comparable, or no, sorry, identifiable protocol. Yeah, okay. Identifiable. That's what it was. Which all SwiftUI views conform to already. All right, okay, now I remember. Okay. All right. Summary for dynamic sorting and filtering. In memory, fast for a smaller number of models, better for filtering or sorting data already queried. Right, that makes sense, yeah. I need dynamic sorting or filtering. Oh, a flowchart. Okay, so either in memory or requery, fast for larger number, better for fetching new data based on filter. And then within the context of requery, you have two additional sub-techniques. You call them fetch, better for displaying read-only data, better for making changes to models. Okay, good to know. So then let's save this one. All right. Dang. Okay, so yeah, I was a little concerned initially that this was too basic, but now I got slapped in the face with it. So yeah. Okay. Either burned or gained a few brain cells. Not sure which one. But yeah, guys, we're going to wrap it there for today. Thank you for coming out tonight. Well,